Okay, so round 2. All right, so graphs of tangent, cotangent, secant, and cosecant functions. So we'll start with tangent. So I guess I should probably put some labels on here since I take points off for that.
Oh, yeah.
You know who you are.
Yeah.
It was more than one person.
I didn't do it.
Well, I know I did. I didn't know what to put there. But
I actually remember both of the graphs. I just didn't remember which one was which. So I just
What grade did you get on me? Not a grade.
no, I'm afraid not to see what I got.
I missed the last two.
All right, I'm going to start with these two to do tangent, and then I'll do the cotangent one. So from this section, all you have to be able to do is graph these parent functions that I'm going to graph here in just a second.
That's a point one or negative one?
-1. Anyways, just looks a little funky because of the way it's on the screen, but all right, so I don't know if you remember, but tangent has asymptotes. What just happened? Does anybody remember where they are or what increments they are? Pi over 2. Okay, so all the pi over 2s.
Oh wait, oh yeah, it's like weird squiggly lines.
Okay, so I'm going to go out and just do it out to the 3 pi over 2s in the positive and negative direction. Okay, and it doesn't have to be perfect. Okay, but the gist of it basically starts here, comes up, and keeps going.
Oh, gosh.
Yeah.
Okay, so when I ask you for the parent function, graph like 3 of them like this, okay? Don't just give me the one little one in the middle. Yes, it needs friends. Now, I don't think we did cotangent last year, but any guesses on what makes cotangent different?
It's backwards.
Yeah, it's backwards. Okay, it's going to be flipped the opposite direction. And also, it has asymptotes at the zeros of the sine function. Okay, whereas tangent has the asymptotes at the 0 of the cosine function. Okay, because remember, tangent is sine over cosine, so wherever cosine is 0, that's where there's an asymptote. Wherever, for cotangent, wherever sine is 0, that's where we're going to have an asymptote. So rather than it being at the pi over 2s, for cotangent, it's at the pi's. So there's going to be one here at the middle as well. Okay, and then at pi. And for this one, you can just do, just because of the way we normally set up a graph, you can just do the 2 of them. I mean, if you want to go all the way out and keep going, you can, but I'm not going to be that picky about it. Okay, as long as you get these middle 2 in here, that's fine for me. All right, so they look very similar. Just now they go more like, oh, that was not good. Try again. They look more like this now. And I'm just gonna put this stuff on here for reference. You don't have to know this, but. I had to redo mine a couple times.
I don't have that luxury with my green pen, so. One of mine looks just like a line that you would get on a coordinate plane.
Okay, so the asymptotes, like I said, are at the zeros of the cosine function for tangent and at the sine function for cotangent. But then on the flip side, I guess, if you will, the zeros of the function are at the zeros of sine for tangent, and then the zeros for cotangent are at the zeros of cosine. Okay, so the stuff that's written in yellow, again, you don't have to know it, just more so for reference, or maybe it will help you if you get there and you don't remember which one's which. Just some kind of things to help you think about that.
I think the only thing that's gonna help me with this is just memorizing.
I mean, your book goes into the elaborate, how do I know how far apart they are? How do I determine the still like period frequency? How do I determine all the shifts, the amplitude, and stuff like that? I just don't feel like we really need to do that. If you can do it for sine and cosine, that's sufficient. You've got a calculator if you were ever asked to do that for something more than sine and cosine.
It's R.
Huh?
The, R, is that R at the zeros of the function, R at the zeros of the sine?
Yes.
That was a bit.
Okay, when we have all this, we'll move on. Everybody have this? I can move it. Okay. All right, so we need to go in and
I don't have all of it.
do a little bit with, thank you.
Could you move it up? Just so we, one above it, yeah. I'm on the, two bottom ones.
Let's see here, roll.
Oh. Lunch isn't going to start until 12:05 today for high school. Because it's pizza day, and the problem is the way the pizza comes, it comes later on Thursdays and they can't get it here, so 5-minute delay. So but lunch goes till 12:35. So you still get your 30 minutes.
I want my pizza at
Like lunch.
Do you scroll up a little bit more?
But if you didn't order pizza, you should be able to go
What's-
get your food.
Okay, you're gonna also need to make an edit to this graph. I forgot when we were doing these next ones. You need to have at least probably 2 tick marks here. 2's fine. Above and below. I'm sorry.
We were just talking about how I can't erase my green pen.
Well, I mean, you should be able to just add one onto it. Whoa. Whoa.
I'm just giving Stacy a hard time, that's all.
An arrow? Yeah, I didn't even do anything. I literally did this and it did it. Now it's not going to do it. It's annoying.
Maybe if you make like a greater than symbol, it'll like make an arrow.
That's kind of cool. The random things that it can do. I'm gonna go ahead and add on some down here too, cause
Yeah, no, I'm just giving Miss Arrow a hard time.
okay. So a couple things. This one's annoying me. It wasn't straight.
More nasty.
No, you did what you did.
Okay, a couple things here. Obviously, secant is the opposite of cosine, and cosecant is the opposite of sine. So we're going to kind of keep that in mind when we're graphing these things. Because they are the opposite of, that means that we're going to have asymptotes, because there are going to be places where it's 0 on the bottom, and we can't have that. So I'm going to put these labels in, and then we'll look at where those fall.
You start to scare me sometimes when you start talking about these graphs.
Yesterday's conversation about people supporting the Gorilla Foundation when we got GameStop was so weird.
We got to hear from Trump in our history videos today. Learning about the men that made America.
Oh, I love that. The show.
The Men Who Made America.
Oh, it's so good. The Men That Built America. And the theme song is phenomenal.
I don't think we saw the theme song because she kind of started it like halfway through.
So unfortunate. Go look it up. It's amazing.
I literally watched all episodes of it. I think my favorite one is still 4.
We're learning about
Oh, so good.
we
I
do
love those. I literally was gonna just go watch them for fun because I enjoyed them so
I
much.
I think they're on.
don't remember his last name.
They were on.
I no longer have Netflix
Why?
because Kenny canceled it.
Why?
Beauties question mark? They're gone.
No, that wasn't why he canceled it. He canceled it because they took The Office away,
Oh.
which is the only reason he had it.
It's that important to
I
him.
think it's on HBO now.
Well, it's on Peacock now, so
Oh.
What is Peacock?
the NBC platform.
Where they used to have Shrek, they don't have Shrek anymore either.
Yeah, so
Yeah, the guy
I don't know.
from
I
Shark
technically
Tank
can get it free with T-Mobile, but that means my mom has to give me the code to do it, and we just don't think about it when I'm actually with her because I tried to sign us up, and I'm not the lead on the account, so I can't do it. So
Yeah.
it's very unfortunate. What color is it taking?
Yeah,
Red.
the guy from Shark Tank was in our episode of The Men Who Made America.
I love Shark Tank.
Yeah, well, I watched a lot of Shark Tank growing up because my dad was obsessed with it.
Same.
that's
It's literally what I do when I'm at the gym. I watch Shark Tank.
I would
They
just,
have it at the
I
gym?
would just go over.
No, I watch it on my phone.
I literally would just like go to say good morning to him, and he'd be like, "Look at this. This is so dumb." And I'd be like, "What are you talking about?" And then we'd watch it for 30 minutes, and then I would be like getting ready because I just.
When I go to the gym, they're playing some random.
Yeah, yesterday they had edible lotion on there. That was really weird.
Oh, yeah, you.
Oh wait, did you tell us that? Who told us? Who told us?
Alyssa was in here when I watched that one, I
There was-
think.
there
Because I was
was
watching it during my
just-
planning period.
Why would you have
internal
edible?
implant for Bluetooth speaker?
Yeah, that was in season
Oh, like in
1.
your ear?
Somebody actually commented, they like mentioned that in like one of the seasons recently. They were like, yeah, I heard this idea. Like, okay. Okay, so this is going to be for secant.
Yeah, that's the whole bottom of the shampoo.
Okay, so with this one, we're going to keep in mind that this is 1 over cosine. So that means that the asymptotes are at the zeros of cosine. Okay, and then for cosecant, it's 1 over sine. And this is at the asymptotes. Or the asymptotes are at the zeros of sine.
The secret one.
Huh?
Yeah, never mind. I asked a question that was already on the board. I said so the asymptotes for secant would be pi over 2, and we already went over that.
Yeah, and then for for cosecant, they're gonna be at the pies. Okay, so these ones again are gonna be on the y-axis and then at all the pies.
Trust.
Okay, so now the thing to remember is that with sine and cosine graphed, okay, the secant and cosecant are going to be opposite of where the little humps are. Okay, just for reference, I'm going to draw in, I don't want to use
Pink.
green. Pink?
Yes, neon pink. Or like hot.
I'm going to draw in sine and cosine and stuff like that so you can see what I mean. Okay, so remember cosine, we start at 1. Okay, so that means that the secant, okay, is going to be, oh, that was bad, up like this,
It's a parabola.
okay? Yeah, basically. They're a little bit more U-shaped than I'm making them, but
Is the pink line the parent function of cosine?
yeah.
Okay, hold on, I need another color.
Where'd my pink go? There it is.
I don't got enough colors.
I'm only really in this one.
Everything's in black. Yeah, I feel like it's too same time.
Okay, so on the edge, I just don't have the rest drawn out. That's why I just kind of made them show that they were going to keep going. Okay, so I would want you to have the middle 3. Oh, good, now you can't see it. What just happened? Okay, anyways, the middle 3. The middle 3 sections are the ones that I would want you to have.
Are those at 1 or 2?
They're at 1. They're just, it's a bad. They're not perfect.
So my graph on the test is gonna be very rough. Very rough.
As long as you have the right general idea,
Okay.
you're good.
Okay.
So
And label things. You're good.
S W and then use sprout from the W.
Yeah, I don't really know how to feel about this.
Okay, and then I'm going to draw in the parent function for sine.
I like reading all the English version.
That it looks just awful, so we're just going to try that again. Sine parent function.
Mine doesn't look great either.
Okay, so cosecant is going to basically look the exact same as secant. It just now is on the humps of sine rather than cosine. Okay, so for test, quiz, whatever it is, all I would expect you to do is to be able to draw these parent functions.
Okie dokie. It seems pretty simple until we get to the last two, but simple.
Okay, and then we're going to skip 4.6, because that's just graphs of composite trig functions, which means a trig function within a trig function, or a trig function that's got other functions within it, and that just is a lot. So we're just gonna skip that section.